project for CS109 cycled through the data process, looked at the number of people who died from the flu, and tried to predict the probability of being infected as well as the probability of recovery. We first looked to aggregate many datasets and perform some exploratory visualizations. Angela scraped the mortality numbers from the CDC. Below you can see graphs like mortality by location or by age groups. We then joined separate datasets of population, the number of people flying city to city, land area, and the nearest associated airport per city, which we scraped from different data sources. We again visualized the mean population for each year. With the flight data, we were able to see the states with the most airplane passengers using a histogram. Now, looking at our theoretical model, a hidden Markov model would be accurate. As we used PyMC, we realized that our original intent to predict the number of people dying was not achievable, since PyMC didn't allow us to model the number of deaths as a convolution of other distributions.
We then moved on to trying Stan, but realized that it also would not allow for latent, discrete random variables like the number of holdovers, cured, and newly infected from timestamp to timestamp. Finally, we moved back to Python and sampled over a grid of possible values for our parameters. Now that we have revised our question of interest to study probabilities, we also revised our modeling assumptions to take advantage of SciPy's skeleton function. We are now more interested in the difference between infected people from timestamp to timestamp and are able to estimate the probability of observing our empirical data across a grid of possible parameter values. Kevin and Mark first produced a contour map of the posterior distribution for one city 1 year, and then expanded it to one city 12 years. We finally included population density as an exposure rate and added flight information.
From this more involved grid, we can estimate the approximate marginal distributions shown on our website and sample from an approximation to the posterior distribution as our contour plots show here.
Just as the course advised, we have iterated through the data science process to revise our models after understanding the languages and exploring our data further. We concluded that from our model, the probability of getting infected is around 0.02, and the probability of getting cured by the next time process is 0.97.